All right, so in this video, we're going to look at two different things. We're going to be looking at identifying the horizontal asymptote and identifying the y-intercept of an exponential function without a graph. So you could put this into Desmos if you wanted to just double check to make sure your answer is correct, but identifying the horizontal asymptote given an equation is pretty easy. So if you think back to what we were doing when we were graphing exponential functions, the horizontal asymptote actually just ended up being this value right here at the end of our function, or our k value. But remember, the horizontal asymptote is always an equation of a line. So we don't want to just say the horizontal asymptote is 2. We want to say that our horizontal asymptote has the equation y is equal to 2. Since our function, remember that the k value moves our function up or down, so our function originally had a horizontal asymptote at 0, but if our y value is 2, we're actually shifting it up 2 units. So in our second example, if our functions looks a little bit different, 2 times 3 to the x plus 3 minus 1, our horizontal asymptote is still this k value at the end. So I'm going to write that as an equation of a line and say our horizontal asymptote has the equation y is equal to -1. And again, that means that our graph is moving down 1 unit from our horizontal asymptote that usually happens at 0 to a -1. So how can we identify a y-intercept of a function without knowing what the graph looks like and without a table of values? So if we think about where our y-intercept is located on our graph, we know that it's along the y-axis, or where x is 0, because x is 0 here, x is 0 here, x is 0 here, x is 0 here. The only thing that's changing is the y value. So to algebraically calculate the y-intercept, what I can do is I can take this function here and I'm going to evaluate it when x is 0. So I'm going to calculate what is f of 0. So that means that anywhere there's an x value in my function, I'm going to go ahead and replace it with a 0, and I'm going to do the calculation that way. So I see that my only x value here is 0, so I'm going to rewrite this as 6 times 1/2 to the 0 plus 1 plus 2. And I'm going to simplify this. So I'm going to work with my order of operations. I'm going to go ahead and simplify the exponent first. That's going to give me 6 times 1/2 raised to the 0 plus 1 is just 1 plus 2. Well, 1/2 to the first power is just itself, so that's going to simplify further to just be 6 times 1/2 plus 2. And my order of operation tells me to do this multiplication. So 6 times 1/2 is the same thing as 3 plus 2. And then I can finally add those two numbers together. So this is telling me that f of 0 is equal to 5. So that means that when x is 0, this is telling me that my y value is 5, and my y-intercept, I always like to write it as an ordered pair. So it's going to happen at the ordered pair of x of 0, comma, y of 5. And that would be my answer for this problem. So let's look at one more. So let's look at the function f of x equal to 2 times 3 to the x plus 3 plus 1. So I'm going to do basically the same steps I did in the last problem, and I'm going to say, okay, my y-intercept is happening where my x is 0. So I'm going to calculate f of 0. So that's going to be 2 times 3 to the 0 plus 3 plus 1. And I'm going to follow my order of operations. So I'm going to simplify the exponent. So that's going to be 2 times 3 to the third power plus 1. And I'm going to evaluate this thing with the exponent on it. So 2 times 3 cubed is really 3 times 3 times 3, which we know is 27, plus 1. And I will finish off by, again, following my order of operations. So 2 times 27 is going to give me 54, plus 1. And I can finally add those together to get myself a 55. So that's telling me that f of 0 is 55. And again, our x value is 0, so that must mean that our y value is 55. So my y-intercept is happening at the point 0, comma 55. And that would be my answer for that one.